Okay, this seems kind of thick, but it's pretty, well, I don't want to say easy, but you need that thing that tells you about the significant digits from yesterday. Okay. Add or subtract the following measurement numbers. Round answers to the degree of precision of the least precise number. Okay, least precise. Actually, I'll tell you what, you are not, yeah, okay, least precise. You don't need this sheet. It doesn't say anything about significant digits. Here's what you do above these, okay? Remember, replace the last one with 1, okay? So 1, everything before it goes to 0. 1. So least precise is this one here, okay? It's always the one with the least amount of places. So when I round, I want 2 decimal places. 2 decimal places. Whatever's in front goes there. So whatever the least, that has 3 decimals, 2. 2's the least precise. Okay, so we put a 10 in front and then 56. Okay, next up, I don't care if that's a 0, you need to replace it with 1. Guys, just put a 0 before the decimal. You don't need to put double 0 before the decimal. That looks kind of stupid, no offense, okay? So that's 1, that has 2, so we just need 1 decimal place. 80.0 plus 7.34. So in front we got 87. Now I only want 1 decimal place. It would be a 3, and it would stay a 3 because a 4 does not move it up. Okay, well this one doesn't even have a decimal, so guess what? It's 1. Okay, 1 whole. Well, I think that one's going to be, so I'm rounding it to 1. That means I'm not going to have a decimal. Okay, so 1472, and it would stay 72. So again, if you have a 1, that means you're not going to have a decimal. 1, that's 3 decimal places. That's a lot more than that, so I'm guessing we're going with 3. So I do the math. Okay, 8 in front. 0, 0, 1, it would stay a 1, okay? 33.92 gallons plus 27 gallons, so that doesn't have a decimal, so it's 1. So really, if it's 1, I mean, you can do this, but that has no decimal. This has 2 places, so we go with the one that's most, or that's least amount of decimal places, so you're going to round to the whole number. Be 60, but it goes 61 because a 9 moves it up. So 1, 0, 0, that's 2 places. Relative, 2, 3, 4. That has a 5, so quite obviously we're going with the one with the 2. Okay, so I'm allowed 2 decimal places. Okay, so 0 in front. Remember, you're only allowed 2 places, so 0, 0, but fortunately that 7 would take it up to a 1. Now some of you might be wondering, what if that wasn't a 7? What if it was a 4? Then it'd be 0.00, okay? Yeah, not kidding. Okay, here's the next one. For each of the following groups of measurement, identify the number that's most accurate, okay? That's the one that has the most decimal places, okay? Actually, no, it's not, okay? Or yeah, it is, never mind. So that has 2, that has 1, that has 3. That's the most accurate. Or no, wait a second. Guys, I'm sorry. Determine the most accurate number. That's when you count how many scientific digits it has. Significant digits, sig figs. So I'm going to rewrite these. I did that wrong. Okay, so mark all your non-zero digits. It's whatever has the most. Okay. Zero is what zeros you have between right there. So that has 3. That has 2. Zeros at the beginning are not significant. Okay, so right there, just put X above it if it's not significant. So this one would be it. Okay, 5.05. I know that seems kind of weird, but it's right. Okay. Put decimals here. So check, 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 check. So that one's set. It has 3. That one has 2. Now what about these zeros? Well, they're not between, and they're not at the beginning. They're at the end. Now, if they'd be after the decimal, they're significant, but they're not. Zeros at the end before the decimal are only significant if there's digits after the decimal. Well, there ain't any digits after the decimal, so all those are X's. So you count your check marks, 1, 2, 3. So 173 is the most accurate, according to significant digits. Okay. Okay, check, 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 check. That one's got 3, we know. Are the zeros between? Nope. Are they at the beginning? Nope. Which ones are at the end after the decimal? Well, right there, that's significant. Okay, so that has 4. How about this 0? Decimals here. At the end, before the decimal is only significant if there are digits after the decimal. Well, there's no digits after the decimal, so that deserves an X. So 3, so it's 123.0 that has the most sig figs. Okay. This is a tie. Okay. They all have 3, so you put tie all 3. Okay. All right, next one. 1, 2, 3. 1, 2, 3. 1, 2. Okay, zeros between. Well, that's a betweener. That's a betweener. So that has 5. That's a betweener. That has 4. And that has 3. So that one's your most accurate. 70,108. Remember, between zeros are easy to see. Okay. 1, 2, 3. Sets that one up. 1, 2, 3. 1, 2, 3. There's a between right there, so that would have 4. Zeros at the beginning are not significant, so X amount. So that this has 3. So 43.08 is the answer. Okay. Okay, zeros at any between ones? No. How can you have between when you only have one non-zero in each one? Zeros at the beginning are not significant, so X, 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 X. So this one's already set. It has 1. Zeros at the end after the decimal are significant, so check, check, and check. So that has 2, and that has 3. So I think it's this one, 0.0200. So 3. Any between zeros? Nope. Zeros at the no. None of the zeros are at the beginning. Zeros at the end after the decimal. That's after the decimal. That's after the decimal. That's after the decimal. So it's a tie. Okay, now we're actually going to apply this. Multiply or divide the following numbers. Round answers to the same number of significant digit as the least accurate number. So 1, 2, 3, 1, 2, 3, 4. So I need 3 sig figs. Now that does not mean 3 decimal places. Okay, so we can get past that right now. Okay. So I take my calculator, 18.9 times 2.373. Okay. Well, 4 is a significant digit. 4 is a significant digit. An 8 would be a significant digit to give me 3. Now it would stay an 8 because a 4 would not bring it up. Okay. You might want to put decimals here. Okay. 2. So that's 5. Okay, so what about these zeros here? Are those significant? Well, they're not between. They're not at the beginning, so I can't just write them off yet. They're at the end after the decimal. Well, they're not after the decimal. They're at the end before the decimal, okay? But they're only significant if there's digits after the decimal, which there's not, okay? So I just need 2 sig figs. Now you got to be careful with how you do this here, okay? Okay, now 1's a sig fig, and then 6 would round to a 7, but you need to complete the number before the decimal, okay? So you need to have a 0 there, so it's 170. Okay, so 1, 2. Remember, that's not a sig fig because it's at the end, but there's nothing after the decimal. Okay, so no. It's kind of a tricky one. 4, what between ones, so that has 4. Okay, beginning ones are not, so we're only doing 2. 2. Okay, so I need 2. The 7 decimal point, there's 1, and then the 6, it would stay as 6, so 7.6. Okay, 1, 1, 2, 3. Zeros at the beginning can be discarded. So we have 1, that's it. 1 significant digit. Now be careful. Zeros at the beginning are not significant, so we write them. Then 5 is my first significant digit, but it would round to a 6. Okay. Okay, sometimes you have 3 factors. 1, 2, 1, 2, 3, 4, 1. Okay, these can be written, you don't have any between zeros. Zeros at the beginning can be written off, so it's going to be probably 1. Okay, I can tell that already. This would be checked because zeros at the end after the decimal are significant, but it's still just 1. Okay, 1 sig fig. So I enter that all in. Remember, the zeros, you write the zeros down at the beginning because those don't count. Zeros at the beginning are not significant, so they need to be written down as placeholders. 4 is my first significant digit, but it goes to a 5. Okay. Okay, next one. 3, 5, that one's set. That's a 0 at the end, sorry if you can't read it. Okay, you got any between zeros? I do. These are between 5 and 1, so they are all checked. Okay, and that's the only between. You can X that out. Now these are after the decimal, so they are. Okay, so that has 1, 2, 3, 4, 6, 5, and 5. So we need 5 significant digits. Remember, okay, so 1, that's a significant digit. The 0 is a significant digit because it's between 2 non-zero digits. 3, so I have 3 so far. Remember, that 0 is not at the beginning, it's between, so that counts. Okay. 2, so check them as you write them down if you want. Then 8, and then 1. So 10.381. Remember, it's by the least, not the most. 3, 3, 2. Now what about the zeros? Well, the ones at the beginning, you can just check those, X those off. X means it's not. Okay, so that has 3, that has 3, that has 2. So you're going with 2. Okay, 0 at the beginning, you put it, but you X it, because beginning zeros at the beginning are not significant. So 2, definitely. And then 4 would be my second one, but it would round to a 5. And there's my 2 sig figs. Okay, now this next one, 1, 2, 3, 1, 2, 1, 2, 3, 4, 5. Okay, your zeros. These are between, so they count. Okay, so that has 6. Now zeros, they're after the decimal. Zeros at the beginning after the decimal are significant. Zeros at the end after the decimal are significant. Okay, so 4. I need 4 sig figs. 270.001 divided by 7.100 times 19.853. Okay, you can write 7, check it. You can write your 5, check it. 4, so we're at 3. Then a decimal I put because I need another one. Okay, here's how that goes. The 9 significant, okay? But it would have to go up, so that goes to a 0 and this becomes a 5, so 755.0, and that's 4 because 1, 2, 3, and zeros at the end after the decimal are significant. So there you go. Boom.